Today we are looking at logarithms. By the end of this, you should be able to describe what a logarithm is, rewrite logarithmic equations as exponential equations, rewrite exponential equations as logarithmic equations, simplify logarithmic expressions, and solve logarithmic equations. All of this will be dealt with when we're rewriting from logarithmic to exponential form. So here it is, the definition of a logarithm. Now you've probably seen log before. It's usually a button on your calculator, looks like this. That's log base 10. So if I wanted to find log base 10 of some number, say 100, I would get an answer out. In this case, if you hit log 100, you'd probably get the answer of 2. Logarithms are the inverse functions of exponential functions, meaning that they are the exact opposite of each other. So in the next few examples, we're going to switch back and forth between them. Here we have log base 3 of 81 equals 4. So what we have here is log with some base of some number n equals the k. And when we're switching it using that rule of the definition of logarithms, that turns into b to the k power equals n. So here my base is 3, so it's right here, there's my base. So that means I've got 3, 4 is my k, 3 to the 4th power equals my n value, 81. That's it written in exponential form. Rewriting is just a matter of identifying what your parts are and plugging them into the right form. If we work in the other direction, b is 5, k is 3, n is 125. We want to write it in the form of a log, so log base 5 of 125 equals 3. If I was looking at log base 5 of 125 equals 3, what this is really saying is, what number do I raise 5 to the power of? So 5 to the power of what gives me 125? Well, in this case, 5 to the 3rd power is 125. We're going to use that idea now to simplify an expression. If I wanted to simplify this expression, what I would do is rewrite it. So I'd have log base 2 of 1/8 equals x. What number do I raise 2 to get the number 1/8 out? Or, as in other terms, 2 to what power equals 1/8. In order to solve this, we want to rewrite it in the same base. So 2 to the x power, 1/8 is, well, 8 is 2 cubed, since it's in a fraction, 2 to the negative 3. Set the exponents equal to each other. You get x equals negative 3. So log base 2 of 1/8 is negative 3. And there's it simplified. So we're going to do a lot of rewriting back and forth between exponential and logarithmic forms. Something like this looks trickier. Log base 1/9 of the 4th root of 3. But it's going to be set up the same way. We've got log base 1/9 of the 4th root of 3 equals some number, because what power do I need to raise 1/9 to get the 4th root of 3? Well, let's get these into the same base. 1/9 is 3 to the negative 2, but that's all raised to that x power. 3 to the 4th root of 3 is 3 to the 1/4 power. So this is negative 2x equals 1/4. Divide both sides by 2, or negative 2. We get x equals negative 1/8. So, log base 1/9 of the 4th root of 3 is negative 1/8. For these last two examples, what we're going to do is we're going to solve for x. But we're going to do it exactly the same way. I'm going to rewrite log base 4 of 2 equals x into exponential form. 4 to the x power equals 2. And then we're going to rewrite it so it's in the same base. 2 to the 2x power equals 2 to the first. So 2x equals 1. Which means x equals 1/2. There's your answer. That's all it is. You're just rewriting and solving for the variable. This last one's a little trickier because x is no longer your exponent. X is your base. So here we've got x to the negative first power equals 5. So I'm going to rewrite x to the negative first as 1 over x. Multiply both sides by x, so we get 1 equals 5x. And then divide both sides by 5. X equals 1/5. So if I wanted to rewrite this, I'd say 1/5 to the negative first power is 5. That's it. That's your answer.